Okay, so cycloalkanes are probably the easiest ones to name wrong because you'll be so fixated on counting the number of carbons and counting what's in the 1,3 position. And you know it's a cycloalkane because you can see it. It looks like a ring structure, but you just forget to put it in the name. So that's what I most commonly make mistakes on. Okay, so if I take a look at cyclohexane, so we're starting off super easy. So cyclohexane, again, working backwards. Hex means 6. And cyclo means put it into a ring. So this is actually cyclohexane. So 1 carbon, 2, 3, 4, 5, 6. Now, in this particular example, we need to actually talk about what the general formula is. Remember if I gave you hexane like this, 1, 2, 3, 4, 5, 6, and I said to you, do you have the formula for that memorized? Some of you would say, yeah, sure, it's CnH2n plus 2. I'm not big on memorizing, so I remember if it's just a straight chain alkane, every single carbon has 2, one above and one below, and so I'm taking the number of carbons, I'm multiplying it 2 for the hydrogens, and then I'm adding my 2 at the end. So you can always figure that out from just a couple examples if you have to write it on a test or an exam. A cyclohexane has a different formula, and what happens is, and very, very few textbooks will actually draw it like this because it's extremely awkward. I can't draw at the best of times. I should be getting there. Oops. Okay, so if you actually had to draw it out using C's and H's, that's what it would look like. And this just gets really distracting and really, really messy. So the stick figure for that one is the more commonly used one. But you see right away, because you've made a ring structure and you've joined carbons together to complete it, 2 of the bonds for carbon are taken up bonding with other carbons. There's no end carbons. Therefore, these 2 hydrogens are not needed. So therefore, the general formula for a cycloalkane is simply CnH2n. You don't have to have those 2 at the end to make the Lewis dot diagram with the complete octet. That's that formula. Okay, so this would be an example of cyclohexane. This would be cyclopentane, and my drawing is probably not to scale. So all you're doing is figuring out what it is, putting a cyclo in front of it. Technically, cyclobutane exists. Technically, it would look like this, 4 carbons for bute. In fact, though, because these angles are at 90 degrees, there's too much electron-electron repulsion. You have too much electron density and too much electron density, and that's called ring strain. And so if you get ring strain, the actual ring splits apart because you just have too much negative electrons too close together, so it doesn't exist. I could ask you what it would look like if it did exist, and if I said to you cyclobutane, you just remember to turn it into a square. And same thing goes for cyclopropane. It doesn't exist, but if it did, that's what it would look like. So our cyclos technically really should start at 5 carbons in the ring, and after that, drawing them gets pretty hard. Me trying to draw a 7 ringed structure is just downright ugly. Okay, how do we name them? Let's see, what do we have on here? 1,3 dimethyl cycloalkane. So this is right off the sheet, 1,3 dimethyl cyclohexane. Okay, working backwards, it's got 6. It's a cyclo, so 1, 2, 3, 4, 5, 6. Carbon number 1 doesn't really matter which one it is, because I could make this carbon number 1 because these are all exactly the same. They're equivalent. It doesn't really matter where you start. Because I read clock from 12, normally people pick that as carbon number 1. There's no reason you couldn't pick this one, that one, or that one, but whatever. I make this carbon number 1, and I also count clockwise. So if this is 1, then this would be 3. So this would be an example of 1,3 dimethyl, right? I have a CH3 group coming off the 1. I have a CH3 group coming off the 3rd carbon. I could have just as easily drawn that, I don't know, like this. I make this carbon number 1, and there's no reason I can't count counterclockwise. If this is carbon number 1, this would be carbon number 3. And that would also be 1,3-dimethyl cyclohexane. So if you have to draw it, it's easy. You can decide where 1 is. If I give you something and I ask you to tell me what the correct name for it is, then you have to pay attention to the numbering. So if I gave you this, BRCL, I think it's pretty obvious that you're going to count either in this direction, starting with this is number 1 and this is number 2. So if I count in this direction, what would I have? I would have a 1 bromo and a 2 chloro. If I counted in the other direction, so if I said, okay, here's my Cl and here's my Br, you're not going to like my explanation for this. If I counted in this direction, you would have a 2 bromo, 1 chloro. Now, I need you to time out for a second. If I just gave you this and said, name that for me, you'd be tempted to say, and rightly so, you'd say 1 bromo cyclohexane. But really, is there such thing as 2 bromo? Like there can't be a 2 bromo because let's just pretend I stuck it here. You'd be like, oh, 1, 2. Well, I would say, no, you shouldn't have labeled, let's pretend it's not there. I would say, well, no, that's not 2 bromo because you shouldn't have labeled that one carbon number 1. You should have labeled this one carbon number 1. So there is no such thing as 2 bromo or 3 bromo or 4 or 5 or 6 for that case. So technically, if there's only one substituent group on a cyclo, all you really have to call it is bromo cyclohexane because there's only one way that you can be bromo cyclohexane. Therefore, if I give you a name like this, it's implying that the bromo is in the 1 position. All right, so far so good. Now, I would like my answer for my cyclo to be alphabetically correct. So if it's alphabetically correct, because I've got 1, 2, and 1, 2, it doesn't really matter. So really I want bromo chloro cyclohexane. That would mean then that the chloro actually gets the 1 position, because if I just had one thing on there and I said to you, draw for me chlorocyclohexane, you would just draw something like this. I hope you can see that. You would just draw something like this. That's chlorocyclohexane. And if I wanted to tell you to put a bromo on the carbon next to it, you would then say 2 bromo chlorocyclohexane, because chlorocyclohexane implies that it's on the 1 position. The 1 position. You could also leave the 1 in the name for 2 bromo 1 chlorocyclohexane, which is acceptable. It's difficult to do this not standing at a board and giving you 20 examples in a row. Suffice it to say, we're not going to be super, super picky on the naming the cyclos because we don't actually see a whole lot of cyclos. But when you're naming a cyclo, you would like to have the substituent groups alphabetically in order. And by having them alphabetically in order, the substituent group that's closest to the name cyclohexane will get the 1 position, and then the rest get numbered accordingly. I'm not sure if that makes any sense. Let me give you a couple examples. So let's go back here. Let's say I gave you something that looked like this. The cyclohexane is a very popular choice. If I gave you a chlorine, a fluorine, and a bromine, and I said to you, how would you name this? Well, first of all, you would recognize that in this particular case, you're going to want to number, this one is going to get number 1, because then you have something in the 1, 2, 4 position. If I went this way, I'd have in the 1, 3, 4, so that's not so good. I could start here. Alternatively, I could start here and going this way, and I'd have 1, 2, 5. So this question is easier than the previous one because there's only one way to number this with the lowest substituent groups. It'd have to be bromo in the 1 position, fluoro in the 2, and chloro in the 4, which means if this is in the 1 position, I need to be naming it a bromo cyclohexane. So that kind of takes the guesswork out of it, right? Because this would be 1 bromocyclohexane. What's on my 1 bromocyclohexane? Now let's go alphabetically. I would have a 4 chloro 2-fluoro-bromocyclohexane. Oh, no dash. Bromocyclohexane. Or you could write 4-chloro, 2-fluoro, 1-bromocyclohexane. They're both the same. Confusing, right? Okay, for this one, right, I've got 1-3 position. If I go like this, if I go like this, also in the 1-3 position if I count iodine first. So because I would like this alphabetically, in this particular case, I'm going to put because this is the same as this, is the same as this, is the same as this. This case, I'm going to do bromo-iodo because B comes before I. So it's going to be an iodocyclohexane.
Or you could say 3-bromo,
It's going to be a
1-iodocyclohexane. Both are acceptable.
Iodocyclohexane.